Your inventory call failed. Now make the controller tell you exactly what to fix. A network engineer needs a controller's device list before a change window closes. The first request comes back blocked. Rather than guess, we use the response as a clue. Which resource did we ask for? What action did we request? And did the controller receive proof that we may ask? That is the job of an application programming interface, or API. It gives outside applications a uniform doorway to an application's data. A monitoring tool, controller, and automation script can exchange information without learning one another's internal code. For network automation, that doorway is commonly a REST API carried over HTTP. Picture the exchange as a conversation. The client sends an HTTP request. The server processes it and sends an HTTP response. A request starts with a method, a URI, and an HTTP version. Headers carry context, such as authorization and content type. A blank line separates the headers from an optional body, which supplies data when needed. The response returns a status line, headers, and sometimes a body, often JSON. The method states the decision we want for a resource. CRUD is the shortcut: create, read, update, delete. Post usually creates. Git reads. Put replaces a resource. Patch modifies part of one, and delete removes one. Treat those as strong conventions, not a universal contract. API documentation defines the exact behavior. The response status tells us what happened next. Its first digit is the fast triage signal. 1XX informational, 2XX success, 3XX redirection, 4XX client error, and 5XX server error. Know the landmarks. 200 OK means success. 201 created confirms a new resource. 403 forbidden points to permission. 404 not found points to the target. And 500 internal server error means the server could not complete an apparently valid request. REST makes this conversation predictable. Its uniform interface keeps resource access consistent. Client-server separation lets each side evolve without breaking the API contract. Stateless means each request stands on its own. The server does not use a previous request to decide the next response. HTTP may use TCP underneath, but REST exchanges are still stateless at their layer. Therefore, a protected request must carry the authentication information it needs every time. Cacheability is another REST decision. A stable, reusable resource may be marked cacheable to avoid repeated retrieval. Frequently changing or sensitive data should be marked non-cacheable, preventing stale views and risky storage. REST also includes layered systems and optional code on demand. For CCNA, recognize all 6 constraints, then focus on how uniform interface, client-server, statelessness, and cacheability shape the request flow. Authentication selects what the client sends. Basic authentication sends a username and password in a header, so HTTPS is essential. Bearer authentication sends a usually short-lived access token. An API key identifies a client application, not necessarily a user, and commonly remains valid until revoked. OAuth 2.0 delegates access. A resource owner grants permission. An authorization server issues a scoped token, and the resource server validates it. In every case, protect credentials and tokens. Never paste real secrets into notes, code, or recordings. Now replay the inventory problem safely with Cisco Catalyst Center's documented sandbox workflow. First, send a post request to the token endpoint using basic authentication, supplied only through a secure client or environment. A successful 200 OK response returns an access token. Do not display, save, or narrate the token. Treat it like a temporary key. Then send a GET request to the network device inventory endpoint. Include the returned token in the documented authentication header. The controller validates that header and returns an inventory response in JSON, with managed device details such as hostname, software version, MAC address, and serial number. The demo's lesson is the sequence, not any specific secret. Post obtains temporary authorization. GET reads the protected resource. When an API call fails, troubleshoot in order: method, URI, headers, authentication, status category, then response body. That turns a blocked inventory lookup into a repeatable decision process. APIs provide the doorway. HTTP carries the conversation. REST keeps it predictable, and the response tells you what to fix next.